Okay, in this tutorial, I'm picking up on the animation basics. If you haven't already watched the animation basics, you might want to in order to catch up. So here we're going to create a bouncing ball, and let me show you what that looks like so you can see what we're after. So we, whoopsie daisies, create a ball, yikes, and it will move around the screen. Oh, it looks like I start with a velocity of 0. Let's give that ball an actual velocity. Apologies. 200. Now we're going to create a ball. There we go, much better. That ball bounces around the screen, and it bounces off the walls and moves along very nicely. So to do this, we use a concept from physics, what physicists call a vector. So vectors are components, sort of are two-dimensional, like a line, objects that have a direction. And a two-dimensional vector has an x component and a y component. So if I'm imagining this ball as moving with a x and y component, you can see it's moving right now sort of, actually I'm going to slow it down a little bit so we can see it better, and then I'll talk through that. So in this case, I'm going to give an initial x velocity of 10, an initial y velocity of 100, and run it again, and we'll see what that looks like. So it's moving right very slowly and up. Okay, now it's moving down, you'll notice. So that the y component of the vector is negative. Now it's negative 100, and it's still moving to the right at 10. It's floating very slowly right. So when we represent velocity in terms of vectors, the bouncing is really quite simple. When we get to the top, we just reverse it. So if it's 100, now it's a negative 100. The right-hand vector remains 10. So when you bounce off the bottom, nothing changes about your right-hand motion. The only thing that changes is your downward motion becomes upward motion in this case. I can now change the initial, let's make the initial x velocity 500. Show you what that looks like. Now it's moving right and left much more quickly than it's moving up and down. So it's quite handy. And it turns out that Turtle actually, when you get the position of a turtle, it's returning a vector, what it calls a 2D vector object. So what I've done is this vec2d is Turtle's type for storing vectors. And I have created a speed with an x velocity and a y velocity. And the nice thing about the 2D vectors, if I can show you, import Turtle. So Turtle vec2d is that you can add them, for example. So if I have 100, 100, and I add to that 0, negative 100, I get back 100, 0. So the 100 plus 0 is 0, 100 plus negative 100 is 0. So you can add each component separately. If I added to that 100, 100, I'd get 200, 200. You can also multiply. Oops, you can't multiply that way. Sorry, you can multiply like that. You can double it or triple it. Multiply it by 10. So that is quite nice that you can do that. So now let's take a look at my code for a ball. So a ball is a variant of a turtle. It starts off with a size, x velocity, y velocity, a tick interval, which I'll use to update. And then right now I have tracing. If my tracing is off, then I don't draw a line. If I turn tracing on, I'm just going to draw a line. So we set up our turtle. We turn the tracer off to make the animation smooth. We set our initial speed to xvel and yvel. That's the two x and y components of our velocity. Set our tick interval. If we are not tracing, we pick up our pen. Otherwise, we keep our pen down. And our shape size is just the size of the circle we're going to stamp. And our shape is a circle. Now, when we draw ourselves, all we do is clear stamps and stamp. So that'll get rid of every stamp that's drawn before and stamp a new stamp wherever it is. So that's a very easy way to update a ball. When we move ourselves, this is where we are going to use our vectors. So I am defining speed as pixels per second. Intervals are 1/1000th of a second, so I just have a multiplier here to adjust for that. I don't have to, but for me, I like being able to specify the interval and the speed separately. So, but basically all I'm doing is taking my position, adding my speed to it, and going to that new place. So all I have to do each time I tick, I add speed to position. So you could imagine, if you're going 10 pixels per second to the right, we add 10 to the x component of that vector, and that moves the thing 10 to the right. Then I check if we are out of bounds. So absolute value just says if we're negative or positive, because remember 0, 0 is in the center of the turtle graphics. So if the absolute value of my x component of my position is bigger than the x component of my screen size, I'm just going to set my speed, and I'm going to reverse the x component. So x component times -1. The absolute value of the y position, the 1th or the second item in that tuple, is bigger than the y component of my screen size. Then I'm going to take the y component of my speed and multiply that by -1, which is how I reverse it. So that's how I get the bouncing. Okay. Update position just says move me and draw myself, and tick, much like our random turtle, just says update me, update my position. In this case, I update the screen each time instead of putting it in a separate method the way I did in the animate, although I could do that. Update the screen, and screen on timer, we set a new timer. So this is the place where we set the timers. We set that timer for whatever our tick interval is. And we can change that if we want to try to make our graphics look more smooth or something. We can create a ball, and you've already seen it run. Let's just show you how we could create a second ball. All right, here's one with 2 balls. And oops, I gotta get the window up. Oopsie daisies. Done something wrong. I must not have moved my second ball. First ball worked. All right, see what it says. Oh, you know what I never did? I never called update on the second ball. B2 tick, it has to start moving. My mistake. Very nice, there we go. 2 balls in motion, different motion, life is good. Okay, so if you know any physics at all, you know that acceleration just means changing your speed. So I'm going to add to this a little bit more physics. Let's add self-acceleration. We'll make another acceleration unit vector as well. In this case, let's just make it a, let's pretend that 10 pixels is a meter, so we'll make it -98. That's our gravity, okay? Woohoo, gravity. And just like we have a move, which updates our displacement or our position, we're going to have an accelerate. Self. And all we have to do is say self speed equals self speed plus acceleration. Oops, self acceleration. And then add here self accelerate in addition to self move. Very simple. So we accelerate ourselves, and then we draw ourselves. See if I got that right. All right. Oops. And now our balls are slowly falling in space, just like a real ball does. They will never stop moving back and forth because there's no friction in this. There's just gravity. So this is a frictionless world with gravity. And there we go. Very nice. See the bouncing balls. I can adjust the initial speed. So for example, if this guy, let's make this guy get launched downward really fast. I'm just going to chuck the ball at the floor. And there you can see it. Doing pretty well. Okay, lovely. Let's try throwing it up in the air instead. There we go. All right, so that's pretty nice. If you wanted a challenge, you might make the balls bounce off of each other. That would be interesting. That starts to get towards my hide and seek game or something like that, where the balls have to keep track of and interact with each other. But there's some basic physics. You can make a pretty nice screensaver with this if you were interested in doing so. If you wanted to change down, you could always make it here. Now down will be in the corner. Let's see how that looks. There they go. There goes the ball towards the corner. Slowly but surely, I just tilted my whole world. Let's reduce gravity significantly and see how that works. I can see my world sort of happening more slowly. Slowly we move down. There we go. So lots of ways to play with this. All right.